so that I can test if it'll output to both of these. It'll work eventually. I guarantee it will. What's up, Sensation? I see Sensations in the chat. Ooh, there we go. Nice. Okay, YouTube's up. Bingo bango. Love that. Dude, I can feel it's getting warm in here already. What are we at? 78 degrees. Ooh, yeah. We're starting to hit the summer. That's when it's going to start getting hot. What's up, Ace?
You're going to start hitting the summer in winter. What?
Well, it's, we're going to start hitting the summer soon, is what I would say. It's because it's, what is it? It's, let me see. Is my stream health okay? Stream looks good. Yeah. Oh, it's all happy. Nice. Okay, cool. Yeah, because it's almost March? Almost made it to March? That's cool.
Springtime.
Springtime. What's the weather like over there? Sensation on your end of the pond.
10°C.
I don't speak centigrade, dude. What is that in Fahrenheit?
Celsius.
Celsius. Oh, no, I want it in Fahrenheit. Here. Temperature in... Yeah, I'm just going to say Cambridge. Let's see what it is in Cambridge. Ace said he's going to New York for the first time in March. Nice. March break. And then you're going to the Bahamas. That's cool, man. Bahamas is dope. Let's see. It's 39. That is cold. That is very cold.
Wrong Cambridge.
Yeah, I know you're not in Cambridge. Oh, wait. Oh, you're right. This is...
Wrong Cambridge.
Yeah, thank you. Okay. There we go. Much better. Cambridge, UK. Which... Wait. Yeah, it's 45. That's pretty cold. Yeah, did you guys see? Apparently, it's absolutely freezing in Japan right now. They're getting insane amounts of snow. Has anyone seen this before? Let me see. YouTube Shorts. Japan ski snow. Yeah. Like, the snow is up to... It's up to, like, where the... What is it? To the cranes are or something. This is not what I want to see. What is it? Oh, let me see. Japan ski lift. But it's, like, full. Here we go. This is it. There's too much snow. This is up to the ski lift. Right? It's like completely, yeah. There's enough snow to cover an entire car. I believe that. Yeah. That's nuts. It's too cold. Too cold. Weather's beautiful here in Los Angeles, though. Big fan of that. Wait, where is the Bahamas? I don't know. I don't think I've ever been to the Bahamas. Is it off the coast of New York? No. Bahamas is way down in, like, Miami. What? Maybe I'm thinking Bermuda. Okay, there is this island called Bermuda, which is, I guess that one's like kind of close to New York-ish. Bahamas are down here. Yeah, Turks and Caicos is the other big one. Isn't St. Bart's over here somewhere? Nassau, Georgetown. Cayman Islands, Jamaica. Are you going on a cruise? Nice, dude. I love cruises. Oh, look, the Gulf of America. Yeah, okay, it's Bermuda. That's the one. I remember there was some island that's like kind of close to New York. I guess it's Bermuda. So random, right? Like, this thing is in the middle of nowhere. Like, why is this piece of land here? I don't know. Hawaii's over here. Yeah. That's cool.
Why is Hawaii all the way over there?
Hawaii's over here. Yo, that's a good point. You know, right? Hawaii's kind of like just kind of in the middle of nowhere. But I guess...
To be fair, I know why Hawaii exists, though.
It's a volcano, right? It's a fault line. You got some tiny islands here and stuff. But yeah, my sister's going to Hawaii, and then she's flying over to New Zealand. Which is... Well, that's Papua New Guinea.
Southeast of there.
Oh, it's over here. Oh, bro, I didn't even know New Zealand. I thought New Zealand was up here by Papua New Guinea.
The distance
man.
between Australia and New Zealand is the distance between here and Morocco.
Wow.
So it's not as close as you think it is.
Yeah, it looks close, but I guess it's not. Okay, I get how that makes sense to go to Hawaii and then go to New Zealand versus like California all the way to New Zealand. Wow, that would be a far trip. That's nuts. Okay, cool.
I've done Manchester to Tokyo.
Manchester to Tokyo. Okay. Man, wait. You probably went over the top. You went over the top. Then is what you did. You did this. You went over
Manchester. No, Manchester to Amsterdam.
Oh, that's not too far. Manchester is just this way.
It's north. Yeah.
Yeah.
Where's Amsterdam? The Netherlands. So from there to the Netherlands, and then all the way east.
Where are the Netherlands, honestly?
Netherlands.
Nederland. Next to Germany.
West of Germany.
Oh, it's up here.
Northwest.
I'm so dumb.
Northwest.
Yes.
Above Belgium. That's Denmark.
Copenhagen. Yes.
No, that's Denmark. Amsterdam is over there. Go back to Germany.
Oh, here we go. Okay.
Netherlands. So
no.
to Amsterdam.
Yes.
And that was
And
like an hour and a half.
And then you went Amsterdam to Tokyo.
Yeah, which was like.
Oh, so you probably actually went over Russia then.
At the time, yeah. I don't think you can now.
Yeah. I have a crazy story of it was during my 20s. I went all the way around the world in like 3 weeks. I went LA. Here, I'll show you. It was actually kind of fun. You used to be able to look. I hate that they got rid of this. You used to have like it was called like Google Timeline. You could see where you'd been at different points in the year. But I went from like California to New York to Milan, and then I bounced around Europe for a bit. And then I went from Prague, which is, I don't know, somewhere over here, all the way to Tokyo, and then I went Tokyo to LA. So I literally went around the world in like 3 weeks. It was pretty fun. It was actually unintentional, but afterwards I was like, oh man, that was very cool. Anyways, yeah, today is Tuesday. Looks like we got some good questions up on the deck. Some physics, nice. And anything else new? Wait, today is Tuesday, right? Or is today Monday?
It's Monday.
Holy shit, I fucked up on the announcement, dude. Okay, let me change that. Oh my god, I thought today was Tuesday. Okay, today's Monday. Thank you. Oh, I need a nap or something. I've been teaching a lot this weekend, and I have this one kid who's in need of a lot of help for a statistics class. And yeah, okay. All right, today's Monday. Welcome. First day of the week. We had a really good AMA on Friday. I hope you guys enjoyed that. Our guest was pretty fun. Hope you guys got a lot out of that. I'm gonna start making little shorts out of our AMAs. So I know the AMAs are long, they're like 2 hours long. But what I've been doing is feeding in the transcripts into ChatGPT. So where do I have it, for instance? Yeah, so here's what I did. So we had Perry Kalmus on the stream in December, I think. Yeah, he's the college admissions guru. And so I took the transcript of the whole conversation, and then I told ChatGPT that, hey, you're a world-class video editor. Can you go through the transcript and identify 5 topics that would be good to create viral content that we could make into like short 3-minute videos? And it's very cool. It did it. And it said here, it was like, oh, cool, look, the Netflix documentary and admissions scandal. Here's the timestamps. Here's a summary, and then here's why it's viral. And then why college rankings are worthless. Tim Cook and the non-Ivy success stories. The Persian trick. This is the first video I'm going to do is the Persian trick. I think this is a cool one. So yeah, again, it's just ways about using ChatGPT as a tool to like leverage cool stuff. Because I could go through the whole video, right? I could go through the whole video and try to like figure out what's the interesting stuff. Or I could just have ChatGPT find it for me. Let me change it. That's a little bit out of the way. Okay, there we go. That's better. Okay. That being said, let's start off the stream, do some homework questions, and help you guys out. Cool. All right, let's do it. It's the Sensation Cam. Welcome to Open Office Hours. My name is Dr. Cole, Sex Education, streamer host here at Math, Homework, Science, Homework. Why? That's a good question, Sensation. I don't know why it does. It has to do with, like, see, now it should get it correctly. See, yeah, now it gets it correctly. And now I can, like, pop you out. Well, one second, let me pop you out. Yeah, there you go. Now it's correct. It messes up sometimes. I don't know why it does that. Yes. Okay, there we go. Good. We got a physics question from Rainey today at 4:30 in the morning. Who's asking this? Okay. Interesting. Okay, cool. I think this is question 17 he wants. All right. In the opposite figure, a cuboid. So cuboid, I think a cuboid is just like a three-dimensional shape that's, I mean, it's like is a rectangular prism the same thing as a cuboid?
I would assume a prism's a prism.
All right.
Because it's, triangular rather than square.
Okay, a rectangular prism has 6 faces. Oh, due to its shape, a rectangular prism is also called a cuboid. Okay. So they are the same thing, apparently.
But then it just made a distinction.
I don't think so.
Well, because it said a rectangular prism is also called a cuboid. So it's not a prism.
Oh, well, let's see.
By its own definition.
Oh, I don't know.
If someone says prism, I think triangular shape.
No. Prism doesn't mean triangular. No. Because you could have a Oh, I know what you're saying.
It has to refract.
No. Mathematicians, when they see a box, it's like, is that a box or a cuboid? I don't think a prism means it has to be a pyramid. You can say a square pyramid, or or a triangular prism is not a pyramid, right? Do you know what a triangular prism looks like? It looks like a box of Toblerone. Right? Toblerone, right? Yeah. I love Toblerone.
That's the prism, not the Toblerone.
Yeah. Well, this is a triangular prism. Yeah. Prism, I think, is just a 3D extrusion of a 2D shape. I think, what is a... You're also right, Sensation, that a prism can, reflect light. But here we go. A prism is a solid face that is bound on all sides by plane faces. Okay. So here's some examples of different prisms. So yeah, see, this is a triangular prism. This is a square prism, which is just a cube. A pentagonal prism, rectangular, hexagonal, and a trapezoid prism. Wow. Super crazy. Okay. Well, anyways, there are a bunch of different types of shapes out there.
The question is, can you split light with all of them?
You could. Yeah, for sure. Yeah. I mean, how that works, so light is composed of, I mean, you can split light with a cube, I'm pretty sure. Because, or maybe not. Okay, you need the angle coming in and the angle coming out to be different, is what you need, I'm pretty sure, in order to split light. So light is composed of a bunch of different wavelengths, right? White light is composed of a bunch of different colors on top of each other, which together make the color white. And because the speed of light depends on its wavelength, when they enter a prism, the speed of light is different. So the differences in the wavelengths causes the light at different colors to travel at different speeds, which then I believe causes it to bend when it hits the angle. The speed of light is constant, but it's not The wavelength and frequency vary. Okay, sorry, that's what I meant to say. Yeah, the wavelengths don't change. Wait, no frequencies. Okay, well now we're having like a light. I hate optics, by the way. I am not the biggest fan of optics. Let me see. Light in prism. I think it's called diffraction. The speed of light in a medium varies. That is true. Okay. Dispersion. Okay. It's bending at different angles is what it is. Yeah. I'm pretty sure I don't think you can do it with a cube. I think you need an angle on each side is what you need.
Well, no, have you noticed how all of these shapes are all triangular?
Oh, these are. Yeah. These are triangular prisms. Yeah, for sure.
That's why I'm confused, because it's like, well, I just assumed that they all had to be triangular.
Well, I guess a dispersive prism is technically a triangular prism. Yes, air, glass, area, exactly. Yeah, and that comes down to Snell's law. Here we go. All right, here we go. This is probably a nice little graph of what's happening, right? Yes, the light has different wavelengths, and so that breaks up, I guess, once it's in the prism due to the angle that it's hitting at. Yes, and this is Snell's law. This is where it comes from. If you want to do the math. Okay, but I don't think you can diffract through a 90-degree angle. Let me see this. Dispersion. Can you have light dispersion through a cube or a rectangular prism? Because I think there has to be an angle. Wasn't Snell's law stolen from some Arabic guy? Yeah. Okay. Here we go. While a rectangular prism refracts light, it does not cause dispersion because the second surface is parallel to the first, causing them to reconnect. Exactly. Yeah, okay. So this is kind of the cool thing. So if you put two triangular prisms next to each other, light through the white light when it goes through the first prism will separate into the colors of the rainbow. But then when it goes through the second prism, it'll combine them back such that it's white light again. Yeah. It's whoever popularized get the credit. Yeah. Yeah. Whoever says it louder. I had a story of that in when I was in elementary school or maybe it was middle school. Someone said a joke and no one really heard it. So I said the joke louder and then the whole class laughed. And the kid looked at me. He's like, "Hey, man. Like, you stole my joke. Like, you said my joke." And I said, well, no one heard it. So, I did you a favor. Like, you need to say it louder. If it's a good joke, I'm going to take it. That's called
I've got a joke. I've got a joke.
What's a joke? All right, what's a joke?
My face.
I thought you were going to say, like, I don't know, minority rights or something. But...
Minority...
Anyways. Okay, let's actually do this question, though. Did Sensation shave? Did you shave, Sensation? They're asking you if you shaved.
I shaved you. I shaved with your mom's razor blades.
Oh my god, that would be... I don't know about that. Here we go. And today the kid is Adam Sandler? Who's the kid? And today the kid is Adam yeah. Oh, yeah. Okay, let's do this one. Okay, a cuboid is placed on a horizontal surface such that the dimensions of the base are this. So it exerts a pressure P on the surface here. Cool, awesome. All right. How will the pressure on the surface change when the cuboid is repositioned to be on the base of the dimensions, which are 20 by 10? Okay. So that has to do with pressure and force and area. Okay. So pressure is equal to force divided by area is what it is. Okay. This is pressure. This is force. And this is area. Okay. So, yeah, the interesting thing here, and this is a cool concept. This is why, for instance, I'm going to go on a couple side tangents to like explain the cool things around this. This is why needles work. Needles, have you ever noticed, like, you don't have to, like, press very much in order to, like, pierce something, or maybe not needles, but I don't know, something sharp, right? The reason for that is that the area at which something is like hitting a surface is so small. This is such a small area that when you divide by a small number, the pressure becomes a really big number. Yeah. Okay, cool.
Push pins on a corkboard.
Which depends on a cork. What do you mean a corkboard?
Push pins on a corkboard.
Yeah, push pins on a corkboard is a great example. Yeah, exactly. Right. Yeah, you know, you don't have to push very much, right? It's because the area of that pin is so small, so tiny, that any amount of force creates a huge amount of pressure. That's why puncture wounds are so dangerous. Yeah, so that's why you need to use force when stabbing someone. Yeah.
Depends how big the puncture is.
Yeah, it depends how big the puncture is. Yeah. But yeah,
if you puncture yourself with a needle, you're probably going to sit there and go, "That's annoying." But if you puncture somebody with something that's like 3 millimeters in diameter, you're going to be like, "I'm bleeding out."
Yeah, cause a bigger hole. The classic one is like the bed of nails. You haven't seen this before, right? Yeah.
Good old fakirs.
Yeah, this is always a. So, for instance, yeah, if this stuff, right? This stuff like bugs me out, dude. Like, what? Wait, what is this? Just like royalty-free stuff? Like, come on. But yeah, so you know, I don't know if you've ever been outside and accidentally stepped on a nail. It sucks. Have you done that before, Sensation? Have you like stepped on a nail with your boot?
Oh, I've got a worse one for you than that. When I was 8, I pierced my whole foot with a garden fork.
Oh God, that sucks.
So that was fun times in A&E for a few hours.
Yeah, did you have to get a tetanus shot after that?
No.
No, okay. So yeah, if you were to, so again, let's say you're a person, right? And you step on a single nail. That nail is gonna puncture you. It's gonna hurt. And the reason for that is that, you know, let's say you are a person. Let's say here, let's make this like person. Okay. You have a certain amount of force, right? Which is pulling you down. And that force is in physics due to gravity is what we say. We say the force of gravity, which is equal to the mass times the acceleration due to gravity. So if you weigh like 100 kilos and G is 9.8, right? Then that's going to be equal to 980 newtons. So there's 980 newtons of force trying to hold you down to the ground. So if, for instance, there's a single nail that's hitting your foot, and let's say the area of that nail is, I don't know, like 0.01 meters squared, like a square, like a 0.01 meters squared. It's just very tiny. Then that 980 divided by that creates a pressure of 98,000, or yeah, 98,000 newtons per meter. This is huge. This is a huge amount of pressure. This will pierce a lot of things. Yeah. So,
wait, a Newton meters pascals. Yeah.
Newton per meter squared. Sorry. Yeah. Sorry, I had the wrong unit.
Pascals, and that's pascals, isn't it?
I believe it is. I believe a Newton per meter squared is a pascal. Yeah. Yeah. Right. And that's 1 atmosphere. Okay, interesting. Yeah. So that, would you guys say 1 times 10, 1.01? Yeah, because it's 101 kilopascals. This is equal to 1 atmosphere. Yeah. Right. Okay. But let's say instead of a single nail, right, you have a bed of nails. You have a bunch of these nails. Now the amount of area that this 980 newtons of gravity force pushing down is distributed over is a lot bigger. It's, you know, it's probably, I don't know, probably 10 or 20 times the area. So that decreases decreases, once this goes up by a lot, it decreases the pressure by a ton, which is nice. Do you want to do a brain rot quiz? What's a brain rot quiz? I mean, you can send it in my chat. You know what else is massive? I don't know, man. What else? The U.S. deficit. The low taper fade. Yeah, low taper fade. I feel like the low taper fade was around like 4 or 5 years ago. Trump's hand. His hands are tiny, actually. Anyways, so this is the cool thing about pressure, force, and area and stuff. We could also go into like Bernoulli's law and stuff and how hydraulics work. There's a lot of really cool stuff with pressure and forces and areas. But for this question, let's just see what happens. Okay, so we're asking about the pressure. Okay, So we know that pressure 1 is going to be equal to F1 over A1. And then that P2 will be equal to F2 over A2. Okay? We're going to compare what these are. In both cases, the force of gravity for the block, whether it's oriented like right side up or like flat down, doesn't matter. The force is the same. We say that the force of gravity is constant. Because the force of gravity doesn't care about the orientation of the box. It just cares about the mass of the box. Let me say M1 equals M2. Here, we can get rid of this. We don't need this. Mr. Happy Man. Okay. So we can say F1 equals F2. Okay. However, the areas are different, right? So the area when it's upright like this, the area that it's touching the ground is going to be 10 centimeters by 5 centimeters, okay? So we can say that A1 is equal to 10 by 5, whereas A2 is then going to be 20 by 10. Does that mean some things can only float in certain positions? Ooh, that's a good question, actually. Yeah. I mean, I think that's valid. I mean, have you ever noticed in your pool, you can't really float if you're just like putting your feet down. You kind of have to like distribute yourself across the top of it, right? The force is, yeah, the pressure. That also has to do with surface tension. I think surface tension plays a big role there as well. Which is kind of more of a chemistry concept, I think, maybe. But yeah, buoyancy is only dependent on the amount of volume of a thing that's submerged. So yeah, this starts to go into like a bunch of different places. No, buoyant force is proportional to volume. It's not proportional to surface area. Why don't boats taper off at the top instead of the bottom to make the surface area with the water less? I think it has to do with stability. Are you saying that like why does a boat look like this versus why does a boat not look like this? Is that kind of like Is this the difference? Yeah, okay. Well, the main difference being you can't fucking store shit here. Just from like an economical point of view, there's not much area here to store things on the boat. And actually the first boats were kind of like this. You ever guys seen like the Civil War boats? Civil War like submarines? They were kind of dope. Maybe not submarines. Civil War boats. Yeah, this is what they look like. So, I mean, they kind of did look like this. Very interesting. Because of Archimedes' principle? Sorry, what's the Archimedes' principle again? It's just the volume thing, right? Yeah, exactly. Okay. Archimedes nuts. Okay. Yeah, that's what I was talking about. Like, so the buoyant force is always proportional to the amount of volume that is under the water, basically. Yes. Again, I think we do things this way because you can utilize more space on the top to do stuff. And I think this is more stable for some reason. I'd have to remember why that is. I'm not a boat designer. But yeah. They both work. Okay. So A1 is equal to 50. A2 is equal to 200. So that's going to be a factor of 4. So I can already tell, right? If this goes up by a factor of 4, then the pressure is going to go down by a factor of 4. So that does mean it's going to be A. But we can show kind of analytically why this is. Wave cutting ability. Ooh, I like that. Yeah, okay. That's the stability thing I'm looking for, right? Okay. So this is F over 50. And then this is going to be P2 equals F over 200. Right? If we divide these all through by each other, then the F's are going to cancel. And you're just going to get that P1 over P2 is equal to, this comes on top. This is 200 over 50, which is equal to 4 over 1. So this implies if you multiply this and then divide by 4, P2 is equal to 1/4 P1. Right. So yeah, answer is it's going to decrease. Increases by P over 4? Wait, that's kind of weird. Wait, what? Doesn't increase. That is so weird. Decreases by 3/4 of P? Yeah. I don't know. I would want to say like by a factor. I would want to say like a factor of 4. It's not increasing. It's decreasing. Yeah, the increase. Yeah, again, I didn't either. And to be honest, this is some fuckery here for them to do that on a question. You never see this. That's like,
you gotta get in the hospital now.
Yeah, that doesn't really happen. It's usually they'll say like by what factor, and you would say by a factor of 1/4. I would say it changes by P over 4. But okay, cool. It decreases. Okay, so so this is so dumb. So P2 is equal to P1 minus 3/4 of P1, which equals 1/4 of P1. So this is decreasing by 3/4 P1. Yeah, weird. That's a weird question, honestly. Oh, we're not in golden hour anymore. Let me switch this. Yeah. Yeah, the decreasing, that's kind of whack. That sucks. I wouldn't do that, you know, to people. It's just mean. But yes, good question there, Rainy. Fun. Yeah, asking for the absolute change is pretty weird, to be honest. It really is. Let's see. We got another physics question coming up. And then Shantrick says, we have something that's a headache to solve. Oh, man. I don't like headaches. Let me do this real quick, just because it's easy. It'll probably be easy. Which of the following graph represents the total pressure acting on a submerged object below seawater and the object depth from the sea level during the gradual rise of an object until reaching the sea surface? Rho equals rho 0 plus rho GH. He says, wait. Why is it not A instead? Well, why is it answer B? Okay. Yeah, what is this PA though? Remember, rho is not P. Yeah, I agree with that. Yeah. Let me see if I can find it. What's it? Pressure.
And 2 V's do not make a W.
It's interesting. So the buoyant force actually does not change based on the depth. That's the cool thing. That's what I was trying. I remember something doesn't change based on the depth, and it's like once the object is completely submerged, the buoyant force is constant, no matter like where it is. Yeah, that's what I was thinking about. Okay, yeah. So this is what happens. So when you have like some water here, right? And they're saying H is the depth from the sea. Yeah, so they're saying this right here, this is H. Okay, so this is like positive H, this is like negative H, basically. And then I guess you have like an object. Yeah. The total pressure acting on it below the seawater. Yeah, okay. Yeah, so there is like P naught. This is equal to the atmosphere. This is the pressure up here, which is pushing down. And then you also have all the water that's above it that's pushing down. And then this is rho GH. So you would say that P total is equal to the initial pressure just from the atmosphere plus rho GH of all the water on top of it. Which, yes, you're very, very, very right, Freak Show. It looks like y equals mx plus b, right? Yeah. So it's basically like y is equal to b plus mx, which is linear. Linear and positive. So that's got to be choice B. And then I believe here, like, PA equals P naught, which equals the atmosphere. Yeah. Row, row, row your boat. Hits the Dr. Goldstream. Yo. Yeah, let's make that. Let's make that the... I'm down for it. Let's do it. One sec. I gotta change that. Row. 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 Row your boat. It's a Dr. Goldstream. Good to see you, Zach. I was at the gym checking out y'all's one second, wait, let's put this up. There we go. I was checking out your linear algebra stream this morning. I was doing bench press. That's what I was doing. But shout out to Zach. Zach's a great guy. Learning linear algebra. Nice. Okay, this is easy. This is done. All right, let's give this to Rainy as well. Okay. Row, row, row your BT. Your BT. All right, let's see. Were you doing the I can stretches? What's the I can stretches? I never stretch, actually, at the gym. I'm the worst with that. I really should. I really don't. I'm absolutely terrible. Okay, let's see. Here we go. PJ starts with m equals 500 and chooses a positive integer n, where n is greater than or equal to 1 and less than or equal to 499. He applies the following algorithm to m and n. He sets r equal to the remainder when m is divided by n. Okay, you'll be right back. Okay. Yes, we can do your question next, because this looks like this is going to be a pain in the ass. Ace is at dinner. Is your brother around? Is your brother around? Is Rec around? Freak Bob says, piece of cake. What type of cake? This is a question of beggar's method. Have you ever heard of it? I haven't. What's the beggar's method? Let's read on it. Distributing identical objects among distinct recipients. Where C is the number of identical objects and R is the number of recipients. So is this n plus r minus 1, choose r minus 1? Or choose r minus 1? Yeah, here, Reki, we'll do yours. And then I'll start researching the beggar's question. Yeah, here's the question so far. Take a screenshot of it real quick, because I'm gonna help Reki with his. Yeah. Get yourself a screenshot. Got it. Okay, cool. All right, here. Let's help out Reki until Shantrix gets back, and then we'll go back to the pane. Okay. Oh, this looks fun. Determine the rule for the number of circles in the nth figure. Use your rule to determine the number of circles in the 15th figure. Well, they kind of like helped us out here, didn't they? Yeah, these are fun, Zach. I like these. They kind of already did the data for us, which is nice, right? All right, so 1, there's 1. 2, there are 6. 3, there are 11. Let's see, 2, 4, 6, 8, 10, 11. Okay, that makes sense. And then 4, there's 16. It's an AP question. AP pre-calc. I heard AP. So I'm actually very curious what college credit AP pre-calc actually gets you. Because most of the time you go to college, like, you're not taking pre-calc. You're taking calculus. Okay. The first thing I would do is try to see if there's like some pattern between the things, which I think there kind of is, right? We see how this is like, I always like to look at the differences between things. So the difference between this is 5, difference between this is 5, difference between this is 5. And that makes sense because every time you're adding 5 circles because you're adding another circle to each one of the starfish legs. I think it is an arithmetic sequence. Am I wrong? I think it's just 1 plus 5n. Or at 5n minus 1. I think that's literally all it is. Good, Saint. Yeah, 5n minus 4 is what it technically is. Yeah, this is an arithmetic sequence. Because you're just adding numbers. Yeah. This would be cool if it was doing like some weird stuff. But yeah, you can basically... oh no, Darsh. Yeah, so this is just 1 plus 5 n minus 1. Which, yes, for the 15th figure, plug in 15. 15 minus 1 is 14. 14 times 5 is 70. 70 plus 1 is 71. Now here's a question. Did they say, did we use inductive or deductive reasoning? Huh. Isn't it technically inductive when we have like a base case and we show what happens for the n plus 1 case, and then we say that must happen for everything else as well? I mean, this is good. Yeah, okay. What's the difference between inductive and deductive reasoning? Okay. Inductive reasoning, I believe, is judging something happening in the future based on what happened in the past. Inductive, yes, good. It means that you found a pattern. Yeah, exactly. Yeah. What would deductive reasoning be, Zach? What would you call deductive reasoning? Deductive means a proof. Oh. Yeah, like, I really like, I used to have such a, I don't know, a dislike for inductive proofs. But they're actually quite fun. Typically based off of axioms. All men are mortal. Socrates is a man, therefore Socrates is mortal. Yeah. Yeah, basically what you show is you have what's called, like, I think the base case, right? You say, like, for instance, like, a sub n is equal to 1. And then you show that a sub n plus 1 is equal to a sub n plus 5. And if this is true, that means you can now rewrite, for instance, that a n plus 2 is equal to a n plus 1 plus 5, and so forth and so forth. Like, if you can show that going from one term to the n plus 1 term is a well-established equation, then you can keep repeating that all the way out to, like, the 15th term. Oh, sorry. Oh, it's a of 1 is equal to 1? Is that how it works? Let me see, like, let's pull up, like, a fun, like, proof. Rocks can't fly, I can't fly, ergo I'm a rock. Oh, Endar says, show a sub 1, assume a sub k, Prove a k plus 1. Ah, okay. Yeah, okay. All right. I want to see like a math induction proof. Let's do one. Let's see one. By demonstrating it holds for the smallest number, so you have to define a base case, showing that it is true for any number k, and it's also true for the next number. This is the k plus 1 is called the inductive step. Oh, it's different than inductive reasoning. Oh, I didn't know that. I kind of lumped them all in together. Pattern generalization is inductive reasoning. Yeah. This is kind of fun. Okay, I just want to like kind of show like an induction proof, because I think it's pretty fun. What's up, Fembox? Good to see you, bro. I saw you. You were being talked about in the Matrix linear algebra thing this morning. I saw it was something about Fembox and Laz. Laz, you were both in on the text somewhere. Oh, wrong link. Okay. I want to prove one of these things. Which one do I want to prove? I feel like I want to prove this one. Can we prove this? Let's try and do it. Oh, you're at work? Yeah, I saw your name somewhere. Zach, what was his name? His name was in the questions, I think. At some point. Okay. So this is saying that 1 plus 3 plus 6 plus n times n plus 1 over 2 is equal to n times n plus 1 times n plus 2 all over 6. Kind of horning in on Zach's territory. Oh, okay, wait. He says these are his favorite examples.
Check this out. I'm going to show you how I afforded this car.
Well, how I afforded this car?
All right.
Two is more than 8 and 16, right? It's very nice.
Math parody of Hallelujah? What is this? This looks intense. I don't know if I can get to this. Oh, but it looks like there's music with it, though. That's fun. Oh, this is 3 blue, 1 brown. Oh, yeah, this guy's cool. He's like a big math guy. Okay, let me see if I can do this one. Just curious. So, I guess this is what we're trying to prove. We're trying to prove that this is equal to this. Oh, it's a parody of Hallelujah. Oh, I get. They probably sing along with it too, right? Yeah. So, I guess what we're saying is that the sum from n equals 0, or we would say from a equals 0 to n of. No, how does this work? Sorry. A equals 1 to n of n times n plus 1 all over 2 is equal to n times n plus 1 n plus 2 over 6. This is like what they're asking you to prove. That like some series summation is equal to this. So I guess the first oh, sorry, yeah, sorry. Yeah, this is A. Yeah, sorry. This is A, and then this is N. Yeah. Yeah, exactly. My bad. Okay. So we gotta prove P1 is true. We gotta prove like a base case, right? So can I just show that n equals 1? Yeah. All right. So let me say like assume n equals 1. Okay. Then that's the sum from a equals 1 to 1 of 1 plus 1. Or sorry. Let me do one sec. A plus 1 over 2, which is just gonna be the first term. So that's 1 times 1 plus 1 all over 2. So that's equal to 2 over 2, which is equal to 1. And then if we did the right-hand side, we'd be like, does this equal plugging in for here, which is 1 times 1 plus 1 times 1 plus 2 all over 6, which it does, because 1 times 2 is 2, and 2 times 3 is 6. Okay, cool. So that checks, right? That works. Okay, so now we say assume P of K is true for some n equals K. Okay. Uh-huh. So we got a base case that works. And then do I just plug in n plus 1? Is that all I do? Well, here. So we prove n equals 1 is true. And then we assume. Oh, okay, I think I'm starting to get it. N plus 2 over 6. And then we prove. Right. Yeah, right there. They assume it for some K. Here, let's just do it this way. Sorry, that's what I want to do. Oh, I think it's starting to make sense to me. Okay. So now what we do is we replace this 1 with a variable K. And we say, okay, we assume this works, right? When K was equal to 1. So can I show that this is also true for K plus 1? So now we got to prove K plus 1 also works. Okay. So this would be from A equals 1 to K plus 1. A plus 1 over 2. And then here we would replace this, right, with K plus 1. K plus 1 plus 1. K plus 1 plus 2 all over 6. Okay. So this equals K plus 1, K plus 2, K plus 3. Sorry, not equal sign? That's equals question mark? You need to prove the left hand side actually equals that. Okay, cool. See that? Yeah, this is the part I mess up on. Okay, all right. Okay. Oh, I think I see what we're doing. One sec. I'm gonna move this down. Reki, do you know how to do this actually? Or are you learning? One sec. You're learning. Okay, good. Okay. Yeah, this is what I want to say. Okay. So we know when we go up to k, it's equal to this, right? That's equal to k plus 1, k plus 2 over 6. And then we're adding another term. We're adding a k plus 1 term. So then this is plus this thing. This would be the next term. That would be k plus 1. So this would be k plus 1. K plus 1 plus 1. I think that's the right way I'm doing it, guys. Right? Because if you go up to k and you get this, which we showed did work when k was equal to 1. So now I'm saying, okay, yeah, here, maybe let me explain this a little bit more, just to kind of show what's going on. So this we know is equal to the sum from a equals 1 to k of a plus 1 over 2 plus the k plus 1 term. So this is equal to this to k plus also this term for k plus 1. That's actually really cool. I forgot that's how that works. Can we move over, please? Yeah, okay. Oh, what's the E? E means sigma. This means summation. Yeah, maybe you haven't done this before. This means just adding up these terms, plugging this in, plugging this in, and then increasing it up until you get to K. Yeah, E equals sigma. Yeah, okay. If you want a quick explanation about what sigma is, let's say you have sigma and it's A equals 1 to 5 of A squared, right? This would be equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So this says do this thing, plugging in 1 for A, and then add it to bumping this number up by 1. So this is, for instance, A equals 1, this is A equals 2, and yada yada yada, and then this is A equals 5. Yeah, this is called a series. They're very important. They're one of Zach's specialties. Because then they can become infinite series if, for instance, the 5 tells us we stop. This is where like you stop. So we stop at 5. In Zach's case, he likes to do things where this goes to infinity. So really this just like keeps fucking going. Yeah. Okay. Oh, Ace, you're back from dinner already. Wow, nice. Three to the 2 high 3. That's too funny. Yes, dude, pi is 3, dude. I love that. Lol. Okay. All right, so okay. So we know to the k plus 1 is equal to the same thing as stopping at k plus adding the k plus 1 term. Like plugging in k plus 1 for this one. So when I get to this, now I think all I have to do is just like show that, let's just add like some common denominators, right? So this is the same thing as, sorry, 3 times this over 6, right? So, oh, that's kind of messy. What? It's okay. K plus 1, K plus 2, plus 3, K plus 1, K plus 2, all over 6. Right? Oh, very cool. Oh, this is really fucking cool, actually. Oh my god, this is so cool. So look at this. Do you see how these things are in common? which means we can then combine these two things. Like, I can factor this red thing out, basically. So now that becomes k plus 3 times k plus 1, k plus 2, all over 6, which is the same thing as this. So it's the same thing as if I were to just plug k plus 1 into here. Wow, magic. That's super cool. Yeah, and then we prove it. Yay. Wow.
Well done! Well done!
Yeah, see, even that is something that constantly fucked with me in, like, high school. And even in college, honestly. Like, induction proofs. And that's why I enjoy doing them now. Because it kind of, I don't know, it's like the boss battle that you kept losing to as a kid. And you're like, oh, I can do it now. Yeah. Why are Germans so good at engineering, Shantrix? I didn't solve the original question? Oh, we did. Well, the original question was that it's inductive because we found a pattern. I got on a tangent and was I wanted to show what an inductive proof was, but it's inductive reasoning. Yeah, you're welcome. Yeah, cool. All right. Okay, here. Let me do aced, because Shantrix, I know you're gonna hurt me with your question, and I don't want to get hurt right now. You said it was a pain in the ass, and I don't want to do that right now. Sensation shaved. Yeah, dude, they keep asking if you shave Sensation. Thanks, Femvox. Appreciate it. I felt good. All right, let's see. Ace, if you're around. Otherwise, I'm going to Shantrix. Let's see if he's here.
Have you shaved? No, I keep skipping through time. You're actually talking to me now as
Bro,
I was 3 weeks ago.
I have nightmares that, like, I shave my beard, and then it's just like... I think about how much time it would take for this to come back.
For me,
because I had to go through like a homeless phase for like a month or two. There's like this phase of going from nothing to this where you look really bad and it feels terrible, but once you push through it, you're good. But I don't want to like go back.
I'm too ginger. I can't be asked.
Can't be asked. All right, let's see. As a large, let's rock. Let's do it. Okay. As a large snowball melts, its size changes. Okay. Oh, this is related rates. Love this. This is gonna be such a fun question. I love these. The volume in cubic centimeters is given by this equation, where r is the radius, and centimeters r goes from 0 to 30. The surface area is given by that. What type of polynomial function does each formula represent? Sketch a graph of each function. State the domain and range. Yeah. It could be a related rates question. A lot of times what they'll ask is like, how much is the surface area changing as the volume is changing a certain amount? Yeah. They're getting you prepped for it. Why don't these people use English instead of weird Greek letters? I don't know. Because that's how math works. I don't know. Just. So polynomial functions. So I mean volume. That's a cubic. And then surface area. Is a well, no. It kind of makes sense that cube volume, right? Even though this is a sphere. Quadratic. It's kind of weird that it's called quad. Why is it called quad? Because it only goes up to power 2. Why do we say quadratic?
4 sides.
Because like, because like quartic, right? That's when something is like x to the 4th. 4 quadrants? I don't know about that. Okay. Determine the average rate of change of the surface area of the volume as the radius decreases from 30 to 25 and from 25 to 20. Yeah, okay, cool. Very cool. All right, so let's do it. So average rate of change, right? So average, or you can say this. You could say like delta SA, delta R. So this is saying the rate of change as the we have a change in radius. Which is going to equal SA final minus SA initial. I don't. Yeah, and the rate of change. This should be over delta R, right? Shouldn't this be over delta R? You just say A rock. That's cool. Okay. So surface area. So that's gonna be 4 pi. And then we're gonna say, I'm gonna do everything in centimeters. 30 squared minus 4 pi 25 squared over 30 minus 25. Which is just calculator intensive. And then I'm going to show you the calculus of why this is actually cool. It's actually a pretty cool thing, honestly. It isn't calculus. Yeah, no, it's pre-calc, but it feels like calculus because it's very close. Where are we getting these numbers from? Okay, that's fine. So surface area, right, is 4 pi r squared, okay? And they want us to know the rate of change as the radius goes from 30 to 25, okay? So this one is RF equals 30. Sorry, no. I fucked this up, sorry. RF equals 25. RI equals 30. These are backwards. My bad. Sorry, 25, 30. Okay. Does that make sense, Ace? So, final radius is 25, initial 30. Okay, cool. I wonder if I want to keep things in just in terms of pi. It'd be kind of, it's like, it's prettier. I think I want to do that. I'm going to do it. Okay. Let's just do 25 squared minus 30 squared. And then we're going to multiply that by 4. So, and then we're going to divide that by 5. So this is going to be 220 pi. And then we can look at it for 20 to 25. So final is 20. Our initial is 25. So now we get delta SA over delta R is equal to 4 pi 20 squared minus, 4 pi 25 squared over 20 minus 25. Well, I want to show you, there's something cool that happens with this. And so that is 20 squared, which is 400, minus 25 squared, 525, negative 225. We're going to multiply it by 4. We're going to divide it by 5. And we're going to get 180. So it's 180 pi. Sorry, 625. You're right. What's 525 again? There's something special with 525. It's a number. Okay, cool. That's surface area. So then let's look at the rate of change for volume. So this is delta V over delta R, which is equal to 4/3 pi RF cubed minus 4/3 pi RI cubed over RF minus RI. So, yeah, let's just plug the numbers in. So that's 25 to the third. Yeah, we're going to show you. Minus 30 cubed. Okay. And then we're going to multiply that by 4/3. I hope this is a nice number. I don't think it is. Oh, it's not. Okay. And then we're going to divide that by -5. So we get 3033 and 1/3 pi. So then let's do it for 20 and 25. 20 to the third. How does a mathematician cure constipation? I don't know. How? He works it out by it with a... Oh, God. That doesn't sound good. That sounds painful. Oh, man. All right, times 4/3. Divided by 5. Okay, so what? That's equal to 2033 and 1/3. All right. Pi. So let's see. Is there like a common whatever the thing between these? What's up, Nick? Let me see. The ratio of these decreasing is like basically 1.5, and 220 divided by 180 is like 1.2. Yeah, so not really. I guess you could say compare the change in the surface area to the change in volume. I mean, they both go down, right? And you could say that the volume goes down by a lot more, right? This is dropping like 1,000, where this is only dropping like, 1,000 times pi. So it's really dropping like 3,000. And this is dropping 40 pi, which is dropping like 120. Yeah, so that's how I would compare them. Okay. Determine the average rate of change of the surface area when the surface area decreases from that to that. I mean, that's easy, right? Do you have to solve for the R in each one? Is that what you have to do? I think this question does take longer than learning what what a derivative is. Yeah, exactly. Like, it's weird that they say average rate of change. Is it the change in the volume per unit radius? There are not solutions for the homework in this course. Yeah, this is just like, this is fucking mean, dude. Like, what? Like, what am I supposed to do here? Does it really want me to solve for R here for each one? It just sucks. Okay. 2827.43 is equal to 4 pi r squared. So you can get what r is for this one, right? So 2827.43 divided by 4 divided by pi square roots. Well, that's going to be 15. Yeah, cool. Okay, so r equals 15. I'm guessing the next one is maybe 10. 1256.64 divided by 4 divided by pi. Yeah, okay. R equals 10. they want the rate of change, right? But, okay, so rate of change is usually dy dx, right? That's why I think, like, it's per unit radius, right? So I believe for C... Well, there's no dt in here, right? Yeah. So you have 1256.64 minus 2827.43. And then this is all over 5 minus 10. Okay. So 1256.64. Yeah, that gets you the answer. Well, I thought you didn't have the answer. Oh, okay. So this is just 100 pi. Cool. And then, oh, you don't know how they got it. Yeah. So they just solved for the R for each one. Okay. So here, yeah, 1256.64 was equal to 4 pi r squared. So we just got the R's for each one. I would eat 100 pi and I would eat 100 more just to be a man that eats 200 pies to be with you. And I would eat 100 pies. Okay, so then let's try and get the R's for this one. 1675.52. It's equal to 4/3 pi r cubed. So 1675.52 times 3 divided by 4 divided by pi. Oh, actually, no. Let's not divide by pi yet. Well, yeah, I actually kind of do need to divide by pi, don't I? Yeah. Okay, so here, R equals the cubed root of 400. Sensation, are you dying there? Or are you dying of laughter? Poor Sensation. What happened to him?
Oh no.
Oh no. Sensation down.
I've got a fever.
Oh, you got a fever.
Feel better.
Yeah, I hope you feel better. I hope it's not norovirus, dude. Are you nauseous?
I got ill on Wednesday.
Oh, damn.
I guess it's a chest infection, but
yeah,
my body's not coping well.
I had something too, honestly. Yeah, I've been like kind of fighting something. It's annoying, right?
I don't get sick, so when I do, it hits me like a ton of bricks.
Yeah, that's unfortunate.
I think on average I get sick once every 3 years.
Did you ever get COVID?
I'm immune.
He's immune. Oh, right, because you did the Special Forces stuff. I remember. Anyways, okay, so then this one is 942.48 minus 1675.52 all over the cube root of 225 minus the cube root of 400. What an ugly, ugly number. I'm confused what your teacher's doing here to teach you, because I'm certainly not learning anything. I'm just learning, like, how much I despise this question. I feel like there's a cube root. Yeah, there it is. Cube root of 225 minus the cube root of 400. What does that get us? 570.07? Like, what even is that? Okay. Is that the right answer, Ace? Is that the right answer? Yeah? Okay, cool. I don't really know what that taught you. Didn't teach me anything. Or, well, that was choice D. Is Zach here? Zach was here. Interpret your answers. I don't know. I don't know what to interpret your answers here. I don't know. Volume goes down. How do you solve for R? Oh, well, you take this, you multiply by 3, you divide by 4, you divide by pi, and then you cube root. That's what I did. Why is it 4/3? Because that's the equation for volume. Volume is 4/3 pi r cubed. It's a good number to know. You should know this. We're going to try it next. Freak Bob. We're going to try it next. But, yeah. Okay. Cool. Yeah, this is more fun with related rates. Let me know if the answer is 14. Okay, cool. All right. All right. Anyways, all right, cool. Good job, Ace. If I have time later, I'll teach how it works with related rates. It's called rate measure. What's rate measure? Hacker group released updated tool to activate almost all Microsoft software. Oh, nice.
People aren't adopting Windows 11.
I mean, I didn't.
Windows 10's coming to its end this year.
Yeah, I still have it. Although I think I still need to activate my version of Windows 10 too. Pretty sure I do.
What else? Yeah, more people are actually going back to Windows 10. So.
Well, actually, mine no longer says activation needed. When did that change? I think they.
I don't know.
I think they just got rid of it. My Windows used to say requires activation. It doesn't say it anymore.
I think it just became free, basically.
I mean, it should be. It's just an operating system, wasn't it?
Well, no, you always had to pay for Windows.
I know you did. I used to always do the trick of like I'd call Microsoft support and tell them that I switched out the motherboard and like they were asking for a new code and then they would just give me a new code.
Oh, I go back to where each disk had its own serial number.
Oh, I know. Yeah. But you would just say that like you lost the disk or something. And they would be like, "Oh, okay, here's another code." You're right. I mean, computers used to have stickers, right? Remember they had stickers with the product key on them? Yeah, you probably got it somewhere, right? You know what I'm talking about?
Yeah.
Like here. Windows.
Keygens. Keygens are a lost art.
Oh, we love keygens. Dude, keygen music was the best thing ever, dude.
I know. What was that? It was before my time.
It was so good. Keygen music?
I think it was like supposed to be like Atari 2600 music.
Yeah. But these used to have like these stickers that were on the computers. Where like this was your key or something. Keygen music is so good, yeah, dude. Yeah.
See, fuck all this subscription service bullshit. We need to go back to you buy a piece of software, you own that software.
So I disagree with that. For example, with Adobe. So yes, you used to be able to buy Photoshop outright, and it was expensive. It was a couple $100, maybe even $1,000, I think, to buy Photoshop. Right? We all just cracked it. But then Adobe got smart, and they said, okay, instead of making Photoshop ridiculously expensive, we know 90% of the people using it are just cracking it, and then the 10% of like businesses that can afford to pay for it are actually paying for it. We're just gonna make it subscription based, and we'll make it like $30 or $40 a month. So yes, on one end it kind of sucks where you're like, hey man, I keep paying for this thing, like I don't feel like I actually ever own it, but you're also continuously funding updates for it, and Adobe's doing a lot of dope stuff with their updates. Like I'm glad I pay for their updates and I'm not stuck to like the old version of Adobe, because it seems like every month they're pumping out some ridiculous AI thing that just makes my life so much easier. And I'm like, okay, cool, thank you. And I understand that requires money. So I'm cool having a subscription for Adobe because they're at least like improving the product a lot, and they need funding for it, which I'm happy to give them.
But the problem is it's not a feeling that you don't own the product. You don't own the product.
Correct. It's a service. Yeah. I'm using Photoshop as a service. Yeah.
I mean, what else would you rent unnecessarily?
My apartment.
Unnecessarily a car.
Oh, you do rent cars. That's a lease. You know, a lease is a rent, basically. It's a rental. It's a long-term rental. Yeah, but see, there's no equity in owning the software, right? If I own Photoshop, I can't go sell Photoshop to somebody else, right?
I'm not so sure about that.
Yeah, you can't really, right? I mean, okay, so you used to be able to, and you still can, right? When you can go to GameStop and like trade in your games and stuff. You know, like back in the day of like when nothing was online, right? Everything was cartridges. You would like play through Zelda and be like, I'm done with this game. I'm gonna go sell this game to someone else. Like I'll go sell the cartridge to them, right? And there was value in that. Nowadays, everything is a product key. Or in the case of these free-to-play games, like with Fortnite and stuff, you're just constantly buying like cosmetics and things, and people do sell accounts, I guess, but you don't really own anything. Yeah, at least Adobe can't take away Photoshop if you bought it. Yeah, but they wouldn't take away Photoshop because it's, you know, it's how they make all their money. I don't know. Photopea is better and free. Nothing beats Adobe. I'll just, you know, I used to use GIMP for like the longest time because I didn't want to pay Adobe money. But if you're serious about production and like want to be taken as like a serious person in the industry, you have to use Adobe. It's just how it is.
Yeah.
They're the king of their game. I agree that, you know, what is it? DaVinci Resolve is like a close second in like video editing software, but honestly, I hate DaVinci. Like, it's so fucking
Premiere
confusing.
Pro is better.
Premiere is just great. It's great. Yeah. Photoshop is too good, and they've put in so much crazy AI stuff with it. They now have like, at least in Premiere too, if you have a video clip that is too short, like say you're like filming like a car going through the desert and you're like, oh man, I wish I had an extra 5 seconds of this video clip. It will generate it. It'll AI generate the next 5 seconds for you. All built into their app, which is, it's super cool. I don't know, there's so much cool stuff. And so that's why I'm okay with some subscriptions. Others, I agree. If I'm paying a subscription for something and you're not updating your software, then I have a problem with that. Then I get upset.
That's all I'm saying.
Yeah, the Pirate Bay. Yeah, there you go. Sail the seas. What was the one for the Silk Road? Do you remember what the ASCII art for the Silk Road was?
I'm aware of the Silk Road, but I've never actually seen anything to do with it. So.
Oh, you never? Oh, I used to be on the Darknet all the time. I don't do it anymore. But... Okay.
I heard about the dark web like many decades ago, and went, there's nothing really here for me. Then kind of never used it. So
it was wild, dude. You could buy hitmen, dude. You could like hire assassins.
That was the point. It's like I can do it myself.
I know. Well, not all of us are SAS trained. They're like, yeah, there's a lot of wild shit on Silk Road, dude. I was like, what? Okay, cool. Here, let's see. So wait, Chantrix, do you want me to do this one, which might cause me pain, or do you want me to do? I think Freak Bob actually did this one though. Or then there's this one. This is a pretty easy proof, I think, right? I'm down to check out the algorithm a little bit. Yes, Adarsh, you are next. You are next after Chantrix. Do the question 25. Okay, here we go. All right, we're gonna die. Uh-oh, about to get bad. I'm crying ahead of time.
Oh, no.
Okay. Hey, what's up, Cosmic? Good to see you, dude. Yeah, it was Silk Road, and then it was Alpha Bay, and then it was White House, and then it was... I'm trying to remember all the history of dark web markets. There were a bunch of them. They all got like rugged, basically. Like people always exit scammed, which was annoying. But speaking of, I think Ross Ulbricht just got freed, didn't he? The guy who created the Silk Road. Trump gave him a pardon. Okay, m equals 500 and chooses a positive integer where n is between 1 and 499. PJ sets r equal to the remainder when m is... Okay, so r is equal to m mod n. I believe this is what we call modulus, right? If r equals 0, he sets... Why do we keep introducing new variables? PJ, you need to chill, dude. He sets s equal to 0. If r is greater than 0, he sets s equal to the remainder when n is divided by r. I'm about to just write code for this. Yeah, this is the reason why PJ has no friends, dude. But, yeah. Okay. And then, if s equals 0... Dude, there's another variable? No! PJ, dog. You gotta chill, bro. If s equals 0, t equals 0. Else, t is equal to... r mod s? Oh, man. For example, when he sets n equal to 8, 500 divided by 8 gets you a remainder of 4. Is that right? Probably. This is called arithmetic modulation. It's modulo, Chinese division. Oh, okay. Okay. 500. I just want to see what happens here. Divided by 8. Okay, so 62 times 8. Okay, cool. So he gets... Let's just like run through a base case here. Right? N equals 8. So R is equal to 4. And then since R is equal to 4... S is equal to 8 modulus 4, which is equal to 0. So then t equals 0. For how many positive integers n with 1 to 499 does PJ's algorithm give r is between 1 and 15, s is between 2 and 9, and t is equal to 0? Well, is this step even necessary? Do I even really care about this? Do I care about this last step? I don't feel like I care about this. I don't care what t equals. I just care about it equaling to 0, right? R between 1 and 15. Oh, maybe I'm gonna do the cases where it's not that, right? Is that kind of what we do? Because having a modulus between 1 and 15 means you need to divide by 16, right? I believe so. Well, okay. Let's say, for instance, you had some number modulus 4, okay? The most this can be, or the only values this can take on is between 0 and 3. because you can only have a remainder. You can't have a remainder of 4, for instance, because if you did 8 divided by 4, right, that would be 1 remainder of 4, but that's the same thing. It's just 2. So I know for the problem is M is 500, so it's 500 modulus something else. So let me think about it some other way. If I have 8 modulus whatever, right? Because M is no. Okay. This is fixed, and then we're picking numbers here. Oh, okay. Because think about it. Okay. If you did 500 modulus 400, do you see how that would give you a remainder of 100? Because 400 goes in 500 one time with a remainder of that. So, but sometimes if it's a clean multiple, like for instance, like divided by 100, this gets you a remainder of 0. Do I need all the factors of 500 to like cancel out the numbers that don't work? The solution is insane. Well, thank you, Shantrix. Yeah, here, send me the solution.
Well, I've just seen the most awful thing of all time, and now I must share it with you.
Okay. The never-ending story where Artax dies on loop for 3.5 hours? What the fuck is this?
It doesn't even look photoshopped either.
Jesus Christ, dude. That's pretty good. Okay. Okay. Yeah, the answer is apparently 13. Freak Bob. Here's also the link if you want it, Freak Bob. You can say shit. It's okay, Freak Bob. Yeah, I don't know about this one. That's a little messy. University of Waterloo, yeah, they run this contest. It's called the Cayley contest, I think, or the Pascal contest, or whatever. It's for different grades. Interesting. So there were a couple cases for this to work. Oh wait, S couldn't equal 0 though. Interesting. Oh, okay. So in order for T to equal 0, you could have S equals 0, right? Because then if S equals 0, T equals 0. But S had to be between 2 and 9. So that also told you that N modulus R. And what was it? It was 500 modulus N, right? So you had 500 modulus N. And then N modulus N modulus 500 modulus n had to be between 2 and 9. What meme is this? Oh god. That's too funny. And then for t to be 0, but you can't have s being 0. So then s has to be a multiple of r. So then you have r modulus n modulus 500 modulus n had to be equal to 0. Okay. These are like the rules, I think is what it was. One in 15. And then n had to be contained in 1 to 499. Let me see if I know any modulus algebra tricks. Oh, Chinese remainder theorem? That's what we were talking about, right? Yeah, and I think that was in the solutions. I think they talked about that. They talk about it here, right? N equals BR plus S for some integer B. But R equals AS, so N equals BAS plus S. N is a multiple of S. N is equal to CS since N is greater than 0. Yeah. Okay, this is hurting my brain. I'll give you a point, Shantrix, but... yeah. It's just, yeah. I can't. I can't. This is too much. This hurts me.
You know what
we
hurts
make
me?
a table. What hurts you?
It just occurs to me that I've never actually finished Final Fantasy VIII or Final Fantasy IX.
You know, I've never played Final Fantasy.
So you need to be playing the good games.
I played KOTOR. KOTOR was great.
Okay, I've never played that one.
Oh, you should play that one. KOTOR is fucking great. Yeah.
See, whilst I can understand why, with the brain rot generation of needing instant gratification, they'll play things like Fortnite.
Yeah.
I don't understand those kinds of games because it's like, well, where's your story?
The story is the friends we made along the way, man.
See, that's placative nonsense.
See, yeah, it's for me. Like, yeah, have I played a single player video game in the last 5 years? No, I probably haven't, honestly. I only play video games as a social thing to, I guess, continue friendships with other people, I guess. Yeah.
See, I play games for the escapism value. It's what's a good story? What can I get involved with so I can just forget what's going on in reality?
Yeah, it's like watching a movie. Yeah, I get it.
Yeah, but you're a part of it.
Maybe I should play more single player games. I don't know.
But because somebody was asking me about Final Fantasy the other day, and it was like, what's so great about Final Fantasy? It's like, well, I don't know how good it is now, but I know how good it was then.
Isn't there Final Fantasy Online now? FF Online or something?
No, Final Fantasy 11 was online. Final Fantasy 14 was online.
Yeah. Yeah, then it just turns into a fucking RuneScape basically all over again. 11 and 14.
Never played RuneScape. Never played.
RuneScape was boss, dude. I fucking love RuneScape.
What was the other one? Another Life.
World of Warcraft.
Never played WoW.
EverQuest. Remember EverQuest?
Never played EverQuest.
EverQuest was a big one. Had the sexy elf on the front or something. That's why I loved EverQuest.
D&D or something?
See, I just don't play well with others, so it's...
Oh, that's okay. Yeah, dude, this was EverQuest, bro.
Sexy elf, bro.
Yeah, bro.
Of course.
Yeah, of course, dude. I mean, that was the main attractor, main attractor for a bunch of 14-year-old kids in video game land. It's like, oh, there's a sexy elf on the cover. We should go play the game.
Big old biddies.
Take
and babies, bro. Oh, bro, I'm done.
EverQuest. Oh my god, so great. Anyways, where's Adarsh? Let's see if Adarsh is. Adarsh, come on by, Adarsh. So we can do your question. Nick, when's your train test?
On the 16th next month. I already got a mail. I got the email for it. I got everything, the location, the time, everything.
Nice. Do you have any questions you want to go over?
Yeah.
Can you send them to me?
Tell in your DMs.
Are they? We went over all those.
Not all of them.
Your local hacker says, I have a question for G10 science. I don't get how to balance chemical equations. Like, some are easy and others are very hard.
Oh, I think we did go through all of them. No, there's some on top that we didn't go through. I'm gonna resend them all.
Yeah, go get me some new ones.
Mm-hmm.
Alright. Well, I'm waiting for Adarsh to show up. Until he does.
All of these, okay. Apply.
Until he does, let's talk about Zelda Ocarina of Time. Endlessly.
We fucking love Zelda.
I pinged where the all of these questions I think we didn't go through.
There is something I should point out.
What's up?
Ocarina of Time is the first game to ever get 10 out of 10 from like all the major outlets.
Oh, you did tell me that. Yeah.
And it stands today, which is fascinating because the game really does look aged badly.
But it's still got the 10.
Still got the highest grade of all time.
All right, Nick. Here, let's do your question. Let's do this.
Mm-hmm.
All right. If you earn 10.20 an hour and time, wait, per hour, and there you are, Adarsh. All right, Adarsh, I'll do yours after this. I was waiting for you. And time, and okay. Dude, this wording here is terrible.
Yeah.
10.20 per hour, and then they say time and a half for working over 40 hours. Okay, so this is like overtime. Okay.
Yeah.
So it's 10.20 regular, and then it's time and a half means 1.5 times $10.20 for overtime.
Mm-hmm.
And they're saying you worked 42 hours. Okay. How much money did you make? How would you figure this out?
10.20 times 40, and then
good.
10.20 times 1.5, or I did half of it and then added.
That's good.
And then did that by 2.
Yeah, exactly. Yeah. So yeah, this will get you 408, and what I basically did was, I just took this 4 and I multiplied it by everything, and then I moved the decimal over to the one place because it's 40, not 4. So that gets me 408, and then we move the decimal. It really gets me 40.80, But then this 0 moves it over to the decimal place 1, so it's 408.
Oh.
And then yes, then we have to do this. I liked your way of doing this. This plus a half of it, but you could also just, do you see, what's 1.5 times 2?
I don't know.
It's just 3.
Oh, right, yeah.
Right? Because 15 times 2 is equal to 30.
Yeah.
Move the decimal over. Okay. Now, you just multiply all these things by 3.
Mm-hmm.
So that gets you 106. Or 306. 306. But it's 30.60, right? Because there was no 0 here, so we don't move the decimal to the left. You can also see this, right? This is approximately 3 times 10, so we should be around 30. That's another trick I would do. Instead of like trying to keep track of like how many tens and whatever, I would just be like, 10 times 40 should be 400-ish. So move the decimal so it looks like it's close to 400. Right? Okay. So then
just one second for Dark.
What's up?
So Dark, you've got $2.20 in one hand, and $2.20 in the other hand. How much money do you have?
For 40?
There you go.
Yeah.
440
440.
to bear in mind.
So yeah, so this one's 438.6. You see how that works? Okay, nice. Let me do this one, and I'll do Darsh's. The measurements of poured concrete truck show that 54 cubic feet of concrete has been placed. If payment to the transit mix company for this is to be based on the cubic yards. Oh. Wow, they're going from cubic feet to cubic yards. This is kind of tricky. Okay. So this is how you do. So you're going to say how many yards cubed is equal to some number of feet cubed. Okay?
Damn.
Right? We could say how many yards cubed is equal to 54 feet cubed. Okay? This is where you want to do stoichiometry.
What?
Do you know stoichiometry from chemistry?
I never did that.
Yeah, you did. Okay.
I did?
How many yards and how many feet? What's the conversion between feet and yards?
I don't know.
3 feet are equal to 1 yard. Okay?
Okay.
Okay. So now you put this as a conversion thing here. So you could either put 3 feet and 1 yard here. Or you could put 1 yard and then 3 feet. You generally want to put it like the one on the bottom so that it cancels out the one on the top. Okay? So I put feet on the bottom because I already have feet on the top here, right? This will cancel out a single foot cubed to make it a foot squared. Okay? So that tells me I need to do this 3 more times. Because feet will get me feet cubed. And then yards will get me yard cubed, which is what I want. So when you do the math here, right, you're doing 54 times 1 times 1 times 1, whatever, divided by 3 times 3 times 3. What is 3 times 3 times 3?
9 and then 27.
Okay, good. So what are you doing to this 54 effectively? What are you doing?
You divide 54 by 27.
Good. Do you see how that's the correct answer choice?
Oh. Interesting.
Yeah, that's how it works, Cosmic. Yeah. This is how I like to explain converting units, especially when it's like cubic meters or like meters squared or something. Think about how like each foot here has to cancel out a foot cubed somehow. So you need it 3 times. Yeah. Cool. Okay. Let me do Darsh's, and then I'll see if I can do Shantrix's, and then we'll come back to Marius. Okay? Okay, good. Right.
Thank you.
Yeah, you're welcome, dude. Alright, what's up, Adarsh? Where you at? He's here. Okay. Alright. Log base 2 of 1/4. Okay, I always like to say this is like equal to x, right? We're trying to figure it out what it is, okay? All right. The rule for logs, they call it the BAP rule, okay? It's log base a of b is equal to c. We want to write this in what's called exponential form. This is the same thing as a to the c is equal to b. Okay? This to this power equals this power. I think they call this like base answer power, because it's like base answer, well, whatever. I don't know. So c goes to the exponent. Yeah, exactly. Okay. So in this case, right, this is the base. So I would rewrite this as 2 to the x is equal to 1/4. Right? This is, and now you got to solve for x. You got to figure out 2 to the what equals a quarter. Nice. Circuits lab. Love circuits, Cosmic. Okay, so what is x? 2 to the what is a quarter. That might be a little hard to do, right? First off, I noticed that this is a fraction and this is not. So that tells me that the thing I'm raising this to probably needs to be negative. Because, for instance, 2 to the negative 1, that's 1 over 2 to the 1, which is equal to 1/2. Negative exponents are how you turn, like, regular numbers on top into fractions where they're on the bottom. Okay. It turns out that 2 to the negative 2 is 1 over 2 to the 2, and that's equal to 1/4. So, in this case, you would get that x is equal to negative 2. Another way to do this is to, like, either try to write this like this or try to write this like this. I could say that a quarter is the same thing as 1/2 to the second, which is the same thing as 2 to the negative second. And now that just tells you x equals negative 2. Why did Dr. Gold start streaming? That's a question for 2021 Dr. Gold, so 4 years ago. We're probably coming up on our affiliate anniversary in like June. Because he wanted to mine some new followers and refine his content to 24 karat quality. Oh, famous. Love that. Right. Yeah, it just needs to be 2 to the power of x is equal to a quarter. Oh, you don't have to solve it? You should solve it. What? They don't make you solve this? They just want you to put it in exponential form? Do they want you to write this in logarithmic form then? Okay, you're starting out. Okay. Okay. Well. Okay. This is the same thing, right? As a to the c is equal to b. And then it's, right? Log base a of b is equal to c. So here a is e. So you're going to say log base e. B. Well, that's what you're trying to figure out. So that's like x. And then c is equal to the ln of 21. Is that really what they want? Is that how they want you to write it, Darsh? It's kind of weird. The cool thing here is like log base e, that is ln. So you say ln of x equals ln of 21, and you just get x equals 21. The other cool thing here, this is like e to the log base e of 21, which is equal to 21. Because anytime you have a to the log base a of b, that's just equal to b. If something's being raised to the base of a logarithm, these things go away. And you just get b. E's natural log. Yeah. E's natural log is base E, sorry. That's what I'm gonna say. I thought college was pretty cool. But yeah, everyone has their own path. You can also go back to college. I have one friend, she's 29, I think, and she just started her first year at UCLA. Congrats to her. Yeah, college, you know. I stayed in college until I was like 31 because I was in grad school. College is forever if you want it to be. Anyways, yeah. There's an 80-year-old pushing through your class. Yeah, props to him, dude. I say the body starts dying when it realizes it no longer needs to be here. So if you keep learning things, the body's like, oh, I should probably still be here. Yeah, probably pretty smart. Okay, cool. Does that make sense, Adarsh? Yeah? We'll get into like why this is cool. There's like some other cool stuff that goes on. Yes, Dr. Gold, cool.
Well done! Well done!
Okay. Let's see. I do have to go eventually, but who else we got? Oh, your local Hecker. What's up, Hecker? Let's do some chem. I'll go away well off. Okay, can you see this, Hecker? You can also come up to the stage if you want to, like, say things. Since it's your question. So, yeah, chemistry. Química. I actually have some good videos on these. You don't have a mic? Okay, that's fine. Yeah, you don't worry about it. Okay. I'm gonna send you them real quick. So if we go to my YouTube channel. I think I go here. Okay, here we go. Yeah. So we have a couple videos here I've made. This one and this one. I'm just going to send you them. But there you go. This is my solution for how to do chemical equations, and then here's how to balance them when they get harder. Because sometimes you'll get odd numbers and stuff. Yeah. I think this one like did pretty well. Yeah, this one's got 88,000 views on it. Wow. Just keeps climbing. People like this one. Okay. But let's try to do this. So, whenever I see a question like this, I like to write out what the things are on each side. So in this case, you have nitrogen and iodine, and here you have nitrogen and iodine. And I just pretend that I have one on everything just to start with, right? So here I have 1 nitrogen, 3 iodines. Here I have 2 nitrogens and 2 iodines. I like to look at the most complicated thing first and try to balance it. Here, like, there's not really a most complicated thing yet. So I'm just going to, like, put a 2 in front of here. Because now that'll make this equal to 2. It'll make this equal to 6. So these are balanced. And now all I have to do is balance the iodine on the right side, which I'll do by putting a 3 there, right? Because if that just affects the iodine, and now we get 6. So now we get 2, 6, 2, 6, and this is good. Easy. All right, let's try something a little bit harder. Yeah, okay. Let's just do this one. Let's do the hardest one. Here, I'm just gonna go ahead and just crank it up. All right. This has a bunch of different things in it, right? We have barium, we have hydrogen, we have oxygen. So we got a lot of stuff here. Barium. Or here, let me put different colors. Sorry. Barium, hydrogen, oxygen. Here we have also barium, hydrogen, oxygen. Okay. I'm going to pretend there's a 1 on everything to start with. All right, so that's 1. That's 2. That's 1. There's 2 here. There is 1 barium. But yeah, the brackets, right? So what this means here, Hecker, is that there are 2 oxygens and 2 hydrogens. Okay? So when I wrote 2 here, it's 2 here plus an additional 2 here. So it's actually 4. And then there's 2 oxygens. General rule of thumb. Anytime you see something like chilling by itself, balance this thing last. Like, don't worry about hydrogen until the very end. Okay? It's usually hydrogen or oxygen that you're just like messing with. Okay. So first things first, my barium's okay. I'm cool with that. My oxygen is not, right? Because my oxygen here, I have 2. My oxygen here, I have 1. Notice I'm not going to balance the hydrogen, because there's a lonely hydrogen here. It just makes life easier. So in order to get the hydrogens the same, I'm going to put a 2 in front of this, right? That's going to make this equal to 4. But it's also going to change the oxygens to 2. Oh. Well, now you're done. That's easy. Yeah, this one's pretty easy. Yeah. You didn't really have to do much. Let me see on I have on my YouTube one that's like harder. Let me see what I did here. Okay. I had C8, H18. This is a tricky one. Okay. So, carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Notice that the oxygen is kind of by itself, so that thing I'm going to balance last, all right? And let's pretend I haven't done numbers yet, okay? So this has 8. We have 18 hydrogens. We have 2 oxygens. Here I have 1 carbon. I have 2 plus 1. I have 3 oxygens. And I have 2 hydrogens. Okay. Oxygen is by itself, so I'm going to balance this thing last. Let's balance the carbons first. Well, in order to get 8 carbons on the right, I'm going to put an 8 here. But doing so, we'll change this to 8, but now it's going to change the oxygen to 8 times 2, so that's 16 plus 1, so that's going to make this 17. Okay. Yeah, so before we had 3, but now we have, sorry. I want to do this the right colors. Okay. Now we have 17. Okay. Now for the hydrogens, I have 18 here. So the only way to get 18 on this side is for us to put a 9 on this one, okay? So now this will change this to 18. And now the oxygens are getting even weirder, right? It's because now I have 8 times 2, 16, plus 9. So then now this becomes 25. Okay. Last step is to balance the oxygens. But what I notice here, right, is that this has a 2 on it. And this is the only source of oxygens. So I can't really get 25 out of here, right? I can't, okay? Whenever that happens, you have to kind of think of what would the decimal form of this be. So it's an odd number, right? In this case, it's like 12.5 is what I would want. Or what I like to say is like, you always just write the amount you need, which in this case is 25, and then you divide it by whatever this is. So this is 25 over 2. If, for instance, this was 03, then it would be 25 over 3. Okay. We put 25 over 2. But you're not allowed to have fractions in chemistry. So now you have to multiply through everywhere by this denominator to get rid of it. So in this case, this is going to get multiplied by 2. So that becomes 2. This becomes 25. This becomes 16. And then this becomes 18. And then this is your fully balanced equation. If there's a bracket, yeah, if there's a fraction, yeah, you gotta do it, yeah. You had an interesting one on this one. Here, for instance, you had like I2 and I3, right? So, you kind of think like, oh, I need this to be like 3 halves, right? Because 3 over 2 times 2 would get me the 3. And this could be 1 and 1. So then you have to multiply through everything by 2. So this becomes 2, 3, 2, and then now this one's balanced. Is it hard to get used to college? Like, how much different is it to high school? Yeah, college is very different than high school. I would say it's kind of easier because you don't have to take as many classes, but it's more in depth because you have to do more within the class. Yeah. It is very different, but it's very different in an awesome way. Anyways, does that make sense, Hecker? Make a little bit more sense how you do these? Watch those YouTube videos. They should help you out. I explain kind of my strategy on stuff. Like, I even see this one, right? CU3, cool. 3. N2 is already balanced, right? So that's 1, and then this is just 3. You'll get used to it. It's like an algorithm, but always like try to look for like the most complicated thing and then balance that first. Cool. You are in control. Yes, that's the scary thing, Cosmic, right? You are in control of your learning in college, yeah. So it's like you have ultimate freedom, but also ultimate responsibility. Because if you're not self-motivated and you don't like force yourself to do things, like you're gonna get messed up. Okay. I think Shantrick says some of an infinite series converge or diverge. Isn't that just when R is greater than 1? College is so much easier if you go back when you're older and if you go for something you enjoy. I agree. Totally. Yeah, if you're like forced into a major that you don't like because your parents want you to take it, you're gonna have a bad time. You're gonna have a bad time, dude. W Dr. Gold, I understood this more than my actual teacher. That's cool. That's why we're actual education, dude. Yeah, the brackets get kind of weird. Yeah, make friends. Yeah, friends help. Friends 100% help getting through college. Especially, just having like study partners. Some of my best friends I made through, collective struggles in physics classes. Yeah. It's great. I went back. Yeah, go on, Nick. What's up?
I read Cosmic's what he said. You're in control of your own learning in college. I'm like, oh wait, well that sounds nice. Oh, wait, is it though?
Yeah, it means you have to like. You have to do things.
That's not good.
I know. Well, it's how the world works. You know, once you like leave your parents' place, you have to figure out how to do stuff yourself. You know, it's true.
Yeah.
Right. Can't.
I'm
be,
not the best at that.
University has 3 purposes.
All right. What are the 3 purposes? Tell us.
Library. Women. Pub.
Women and what?
Wait. Library.
Pub.
Women. What? Pub.
Pub.
Pub. Okay. Kind of like that one. That's a fun
And if you
one.
can combine all 3, it's a fucking mental case. But do it.
Okay.
It's a good laugh.
Do it. That's too funny.
Women is crazy.
Women is crazy.
Women and library.
I mean, sometimes both. You can meet
Yeah, I was
girls
gonna
in
say
library, for sure.
I did women in library in secondary school. So.
Yeah. Women library. Yeah. Skilliam says he went back to college for graphic design after the Navy. I work in the electrical field. I don't use it, but I wanted. Oh, yeah. You had so much fun. Yeah. Cool.
Damn.
Yeah, because he was learning about stuff he actually wanted to learn about. Yeah. Makes huge difference. Yeah, put yourself out there, and they're all going to go. Yes, exactly. This is the number one thing I tell students, Cosmic, is always raise your hand if you don't understand something, because I guarantee you everyone else in the class doesn't understand it either. They're just too scared to put your hand up. And yeah, don't be afraid to like ask for help, because everyone else probably needs help as well. I can't tell you how much help I needed getting through college. As like smart as I seem sometimes, you know.
Make sure to raise your hand high enough.
Yeah, I know.
So they see it.
but not half high. Don't do that.
not too high.
Don't do it.
Remember, pet the dog.
Pet the dog.
Call for a
hail-
taxi.
Call for taxi. That's about it.
Hi, Hitler.
Don't do that one. Don't do that one, guys. You ask for help with every day to where it is annoying a little bit. That's okay. It's better than not asking for help. This one, I believe you can do this with like an integral. I believe. I believe this is like. Is it from like 1 to infinity? And it's like a1 r to the x minus 1 dx. Is this kind of how this works? I think it's how this works. It's like writing a sum as an integral form. So then I think you put this over here. I know the rule is that r has to be less than 1, but I forget why that is. Oh, here we go. Integral of a to the x dx is a to the x over ln of a. Okay. There we go. That's what it is. Yeah. Okay. So. Say u is equal to x minus 1, du is equal to dx. Okay, so the x minus 1 doesn't actually matter. So this is equal to a1. And then r is a, so it's r to the x minus 1. Oh, okay, cool. Over ln of r? From 1 to infinity? Mm-hmm. Okay. So then that turns out to be a1 r to the infinity over ln of r minus r to the 0 over ln of 1. Oh, but the ln of 1 is 0. That's bad. So you get 1 over 0? Yeah, I know that. I know that from, like, yeah. That's, like, the first step for, yeah, sequences and series. I was wondering if you could prove it with the integral, though, right? I wanted to see if you could do it. Let's see. Yeah. How do you... I know this is just true, and we end up saying that when we get into series and sequences, and, like, proving convergence and divergence. I want to know if there's a sneakier solution for it, or sneakier proof. Right, these are all the tests you're eventually going to have to learn. Because, yeah, you can prove that, okay, in order for a series to converge, the last term has to go to 0. Right? If the last term doesn't, then it diverges, right? Okay. Yeah, I forget what the proof is, though. Like, I know what the definition is. Oh, this is kind of cool. Ooh, I really like this, actually. Ooh, this is a really cool proof, actually. Let's see if we can kind of understand this one. Okay. So they're saying the sum of a geometric series, right, is A, this is like A1, right? And then it's R to the first, R to the second, R to the third, R to the fourth, all the way up to R to the n minus 1, right? But if you multiply through by R, okay, then this becomes this, all the way up to the A to the R of n. Now, if you subtract the two, if you subtract this whole thing from this thing, and subtract this whole thing from this whole thing, the only term that survives, right, because A to the R n minus 1 is included here, so this one will cancel out this one as well, is going to be A minus AR to the n. Yes, all but the first and last terms cancel out. Ah, and then you can factor out the Sn. And then you divide it. Wow, this is a super cool proof. I really like this one, actually. So, yeah, then Sn is equal to A 1 minus R to the n over 1 minus R. Okay. And then, yes, if n is equal to infinity, right, then R here has to be less than 1. Or the absolute value has to be less than 1. Because if you have a number greater than 1 to the infinity, that's going to blow up. But if you have a fraction like 1/2 to the infinity, this will safely go to 0. Very cool. Yeah, and that's where it becomes a1 over 1 minus r. Wow. All right, that's actually really cool. That makes sense to you, Shantrix? I think it's cool getting the sum Sn, and then if you plug in n for infinity, you can show that r has to be a fraction. That's really cool, actually. Okay, cool. I think we have the questions done today, so let's maybe close the stream out so I can get some dinner before I gotta go teach stats. Okay. Cool. And let's close out. Thank you, everyone, for coming to office hours. I had a fun time working with all you guys. Appreciate all the questions. Appreciate you guys showing up. Our next stream is going to be tomorrow. That'll be at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. So come on by, get some help with your questions.
12 p.m. GMT.
12 p.m. if you're on the British side of things, yeah.
AM.
Yeah.
You said you're gonna do another question for me.
I gotta go eat. I'm starving.
Oh, okay.
But yeah, we'll do more of yours. I mean, send the best way, Nick, for me to go through your questions is I know you've already sent them once. Put them in help screenshots so that I know they're there. Otherwise, it's hard for me to go through all things. Okay, let's go raid someone. Obi's just faffing about. Oh, that's fun. Yeah, let's go say hi to Obi. He looks like he's doing some cool stuff. Okay. All right. Have a wonderful start of your week. And we will see you guys tomorrow. Okay? All right.
Peace.
Peace.
Or they did the work of that stuff later on.